Okay, so for this last example with L'Hopital's, we're going to do one where it turns out to be a very different form. And so we're going to look at this example here where we're going to take the limit as x approaches 0 from the right of cosine of x raised to the 1 over x. Now, first, let's make sure we understand the form that we have. What we have here is a form that is, you notice is as x approaches 0 from the right, cosine is going to approach 1, and 1 over x is going to approach infinity. And so what we get is this form of 1 to the infinity. And this is one of the three forms. The other one is 0 to the infinity, and the third one is infinity to the 0. So these three forms, there's a way that we can use some algebra combined with the calculus to allow us to employ L'Hopital's to answer this question. Now, before we go any further, let's again look at the graph and see what we think is happening. So again, note cosine is approaching 1, right? And this is approaching infinity. And so what's happening is you're getting a smaller and smaller number for your base, right? So you're basically having something like this. You're having a smaller and smaller number for the base b, but a larger and larger number for the value of a. And so, the question obviously becomes what is that limit? Now, if we look at the graph, it appears that as we approach 0 from the right, we are approaching a value of 1. Okay, so that's what we expect to get out of this. Okay, now, I'm going to write this over here. There's going to be one little key thing that we've got to remember from algebra, and you'll see what we are going to do here. But this key idea is that how the inverses of log and exponentials work, and in particular the fact that e to the natural log of, say, t is equal to t. And again, that's because the exponential function and the logarithmic functions are inverses, and so they undo each other. Okay, so what we're going to do when we have one of these three forms is we're going to let's say y equal the function that we're interested in. So that would be this function. And then we're going to take the natural log of both sides. So I'm going to get the natural log of y equal to the natural log of cosine of x raised to the 1 over x. And this is the key, one of the key reasons why we do this, because remember, one of the properties of logs is that if you have this exponent here, you can bring it down in front and multiply it. So what we wind up with is that the natural log of y is equal to 1 over x times the natural log of cosine of x. Okay, so we know that. And at this point, once we've got this exponent down so that we no longer have an exponent, now we're going to take the limit of both sides. Okay, so I'm going to take the limit as x approaches 0 from the right of this side, and the limit as x approaches 0 from the right of this side. Now, note on the right side here that what I wind up with is, as x approaches 0 from right, this is infinity times, now again note that cosine is going to approach 1, and natural log of something really close to 1 is really close to 0. So this is not quite L'Hopital's form, but we can easily make it into L'Hopital's form by switching this function here. So what we're going to do is switch that function there to be, we'll say, the natural log of cosine of x over x. So notice I just did the reciprocal. And now I do have L'Hopital's, because as x approaches 0 from the right, this is going to approach 0, and this is going to approach 0, and so I can use L'Hopital's, okay? So I'm going to say this is equal by L'Hopital's to the limit as x approaches 0 from the right of, so I'm going to get, now I'm going to kind of do this quickly. I'm expecting that you know how to do this. But remember, natural log is going to be 1 over, this would be 1 over cosine of x times the derivative of what's inside, which is negative sine of x. And that's going to give me negative tangent of x over 1. And note that when that happens, tangent of x approaches 0, so this limit is 0. Now, I've got to point something out. This is not our answer, because what we have found is the limit of the natural log of y, not the limit of y. See, we let y be this function here, right? So y is this function right here. But what we have found is the limit of the natural log of that function. So what I have to do is go start kind of back over and say, okay, so what I want, I'm going to take the limit as x approaches 0 from the right of cosine of x raised to the 1 over x. Now, this right here is y. So that's the limit as x approaches 0 from the right of y. And this is where my key step here comes into play. Because what I'm going to do is I'm going to let this be the limit as x approaches 0 from the right of e to the natural log of y. So notice I'm replacing y with e to the natural log of y. So that's what happened here. This becomes this. And that's just because they're inverses of one another. And so then that's going to equal, now we know from here that when we take the limit of the natural log of y, we get 0. So therefore, and e is just a constant, so we have the limit as x approaches 0 from the right of e to the natural log of y will equal e to the 0, which is 1. Which is precisely what we expected it to be via the graph. So this is a way that we can evaluate a limit that is of either one of these three forms right here, any one of those three. This is the setup. You're going to first let y be the function. Then you're going to take the natural log of both sides. And in doing so, you're going to be able to bring down that exponent. Then you're going to take the limit. So this will be the fourth step. And when you take that limit, it probably won't be in a L'Hopital's form, but you can move it to where it is. And you will wind up with some limit after you do L'Hopital's. Generally one time, but it might be possible that you're going to have to do L'Hopital's more than once. And so you wind up with a limit. But again, note that you wind up with a limit for the natural log of the function. And that's where this key ingredient comes into play. So we start back where we wanted. We replace that with y. But we know that y is the same as e to the natural log of y. And I know what the limit as x approaches 0 of natural log of y is. Okay.